video.
At
There we go.
Lockheed Martin, our why is found in connecting, protecting, and exploring. It propels our purpose from the moon to distant planets and the stars beyond. We've been a part of every NASA sample return mission, every NASA Mars mission, and we are building the spacecraft that will carry humans to the moon and on to Mars. At Lockheed Martin, your mission is ours.
So continuing with our senior leadership emphasis this morning, the next session is sponsored by Lockheed Martin. So to introduce our speaker is Lisa Callahan. She's the Vice President and General Manager of Commercial Civil Space at Lockheed Martin Space. Lisa.
Good morning. Our next speaker, oh goodness. Excuse me, Dr. Thomas Zurbuchen really needs no introduction. But in light of Thomas's recent announcement to leave NASA at the end of this year, I can't pass up an opportunity to talk about some of the amazing successes you've had in your career at NASA. Thomas is the longest consecutive serving head of NASA's Science Mission Directorate, and his tenure is arguably overseeing some of NASA's greatest scientific discoveries. We've especially been in awe of the images that are coming back from the Webb telescope. And after holding our collective breaths through the telescope's unfolding and the historic flight of humanity's first Martian helicopter, Ingenuity, of which has gone from a tech demo to an integrated part of the Mars sample return mission by charting Perseverance's path for later Martian soil collections. Thomas oversees over 100 missions, and since assuming his role in 2016, has been involved in selection of 36 new missions. From his very first mission selection, kind of near and dear to my heart, Lucy, which is currently en route to the Trojan asteroids of Jupiter, to Dragonfly, which will be heading to Saturn's icy moon, Titan, and advancing the Mars sample return campaign. From my vantage point in industry, however, I want to reflect briefly on how NASA's Science Mission Directorate and industry partners have changed thanks to Thomas's leadership. A large part of SMD's success is due to Thomas's relentless focus on investing in teams that make these missions possible. Across industry, academia, and government, NASA's mission teams are more integrated than ever before, and open and honest communications has been critical to that. As part of the emphasis of strong teams, Thomas has a passion and advocacy for diversifying the science and aerospace workforce and implementing meaningful programs to foster inclusivity. He's directly involved in multiple initiatives across the Mission Directorate, even co-chairing SMD's Anti-Racism Action Group, which reflects his own stated goal for NASA leadership by leading by example and performing to the highest standards. Thomas is not afraid of risk-taking either, smart risks, that is. He emphasizes the need for innovation in all of its forms, including technological, programmatic, so long as the risks are adequately acknowledged and quantified. Whether for a new instrument to make the next generation of discovery or new ways of going about exploration, SMD is more innovative in its exploration science approaches as a result of his leadership. His impact is not only felt in the agency, but the world over, and his public engagement has helped the agency in, shall we say, a competitive media environment. By helping explain why the nation explores the universe and how it benefits us here at home. Thomas has been invaluable in building and maintaining public support for NASA's science missions. His impact on NASA, industry, academia, and the broader science exploration enterprise will be felt for years to come. And we're grateful for your service. Please welcome Dr. Z.
Well, thanks, Lisa. And I just want to say thanks to all of you who have made these 6+ years at NASA so amazing for all of us, but also for me and my family. So I just really appreciate all of you who have done your part, whether you started a company, built out a company, whether you've brought in new talent, hired those or employed them in our NASA centers or companies around it, or whether you gave your time and came to the US government in whatever role and helped advance what we so cherish, which is exploration in and from space. For us, that's one of those amazing goals that are there and that are lasting and enduring. I'm excited for everything that we're doing now, and frankly, the things that are going to happen long after I leave NASA, and of course, I'll always be a champion there as I try to figure out what I'm doing next. And just to tell you right now, no, I'm not talking to a single company. I tell everybody my email address is my last name at gmail.com. And the only time I start to talk about other things in the future is after January 1st, and I will not answer quickly because I bought a season pass in a ski resort in Utah. So that's my plan for now. Look, what I want to talk to you about today is something that's really dear to my heart. Frankly, something I could not have talked about last year, because there's a major shift happening at the interface of science and human exploration that frankly provides unique opportunities in ways that we have never seen, about combining what are two strong exploration organizations into a single one that can do things that we've never been able to do. I'm going to argue that for us to take advantage of that, we need to learn new tricks, things we've never done at NASA's history, ever. And we need to do it in a way that actually creates kind of an inflow of talent and bringing together of minds, both within the government, the private sector, the international community, in ways that at this moment in time, I could not tell you exactly how the answer is, which is why I think it's one of the most exciting things to figure out in the near future. We're going to decide whether we want to do this, right, in the next 10 years. For deciding not to do it, I would say we all feel more comfortable, but we lost the biggest opportunity, I would argue, in my entire career at the exploration kind of frontier of robotics and human exploration. So that's what my talk is about today. And kind of to set it up, what I want to just remind you, of course, is that the future is stacked. Kind of an astronaut there on the surface of the moon, in this case, with robotic elements, some of them with human landing elements, some of them with industry involvement, kind of NASA involvement, international involvement, doing research and teaching us about our universe. Of course, the Artemis program is where it's at. What we're really trying to do on the moon is not one mission, but creating an enduring presence. The only way we're doing that is by actually focusing entirely from the word go on the things that make it enduring, because we want to use it as a platform to go forward deeper into space to Mars and beyond. The elements for that, of course, are science. We've talked about, that's what I'm going to talk about. I recognize there are two others that I'm not going to talk about. They're equally important, but I'm not going to talk about today. The second one is kind of resource extraction and kind of the ability of using the moon as a resource for the exploration going forward. And the third one is kind of economic pursuits, industrial pursuits, such as tourism and other sectors that yet have to be built. Some of these overlap with each other, but they should be looked at separate from each other as well, because otherwise you over-constrain what industry can really do. If there's anything I believe in, and that I learned even more so in the last decade than I ever knew before, is the power of entrepreneurship and the commercial capability in the United States, second to none. If we build a leadership strategy that does not build that into the DNA of our strategy, we're just missing one of the most important tools. So that's really what I'm going to talk about. Science, of course, is in fact a core of the Artemis values that are there, as is inspiration and national posture. Pam Muller has been very, I mean, I listened to her talking about this, and of course I could do the same. I just want to tell you, all of these things matter. I grew up in Switzerland. That's where my accent is from. Tried to lose it for the last, 30 years or so since I'm in the US, and I'm not going to be successful. I'm sorry to say. I want you to know that national posture in the United States, leadership of a country that loves freedom and stands for it and speaks up for it, is good for the entire world and affects people all over, including a little kid growing up in a farm village somewhere and basically learning about this and eventually ending up the head of science at NASA. So for me, that's what that means, as is inspiration. The books that I got to read, what is in our classrooms. Artemis, of course, has many different parts I'm not going to talk to you about. I put on my Artemis pin today because, very frankly, I'm looking forward to the next launch attempt. And I will show up until this rocket goes up. Even if I pay my own tickets as we go forward. So needless to say, I have every belief I don't need to do that. So there's many other elements. I'm not going to talk about this. I want you to look at this though and recognize that this is an infrastructure-rich, kind of element-rich initiative. So what I'm going to talk about is less about these elements, but more about the how we drive the key priority, which is science. Okay, so that's what we're going to do. You see another way of looking at these kind of in a calendar way is what's already happening, what's in orbit around the moon right now, what we're developing. Lunar Reconnaissance Orbiter being kind of the workhorse kind of science for many, many years, kind of frankly providing information for everybody that lands on the moon, and kind of increasingly important as we look at the moon in more than one way, including also kind of a platform that relates to aspects of exploration, but also of safety here on Earth and otherwise. So there's many things we do in science, which we do in all of these elements, such as surface characterization. You should know whether you're going to sink in with your vehicle when you go, whether you're going to have flat or you're going to be tilted and so forth. And frankly, also helping you find the landing sites, no matter who you are, if you're a private company, and then really map out what you need so you can actually plan your mission. So we're doing that each and every day for many different stakeholders. So what I really want to talk about now, so we've done all this. What I want to talk about is this chart. And kind of if there's only one chart you take home with you or you think about, it's this one. We have done research in two modalities for the entire NASA kind of history. And science, and I'm not talking about technological research, I'm talking science kind of research. We've done it in modality 0, I call it, which is robotics. We're really comfortable with that. I mean, kind of we built spacecraft. The XP spacecraft here at Marshall, right, is doing amazing work looking at and emissions kind of X-rays in an entirely new way, using kind of a focusing optics that developed here. And that spacecraft is up there doing work even when we sleep. Robotic space will always be there. It's what gives us the weather forecast that we, use to dress in the morning. It's what provides value, but also opens up the deep universe. Modality 1 is robotic exploration. Humans are involved every time because the only way we get those to work is humans that build amazing teams from different organizations, different backgrounds, and do that. Modality 1 is basically, I call it science rights along with human exploration. Opportunistic research, I would call it. Yes, there are examples I'm going to talk about when kind of we're flirting with joint integration with the space station, for example. But largely speaking, the Apollo program, programs that we have done so far were built around, rightly so, the safety of humans, the kind of that parameters that develop humans. And then we asked, the next question is, what is the science we could be doing? That's modality 1. Amazing science came from this. I'm not going to go say that these are modalities that aren't worth doing. Just like modality 0, we will continue forever as will we with modality one? I'm arguing though, there are two modalities that we need to learn how to do that frankly, if we try to do it today, it's almost like, that tourist group where half speak one language, the other half speaks another language, and you try to explain where to go. It's very hard, except if there are people in the middle that speak both languages. Those people we need that sit here, some of them are still in school, some of them are out there, some of them have practiced that by moving, around. As they always say, the best, vehicle for technology transfer is a moving van. It's not some kind of legal construct. So science and human exploration jointly implement a vehicle, implement an exploration in that other modality. I'm going to explain to you what that means. You can look at when you're successful, you can tell the story of that vehicle, of that element, starting with science to the end of the implementation, and it is excellent. You can starting with human exploration to the end of the implementation, and it's excellent. It's not an excuse for science. The science requirements, the science objectives were built in at the beginning. The vehicles that we use to figure out how we get science closures are built in from the beginning. They're not at the end attached like the sticker on the back of my car. They're there from the beginning and they're built around it. And the final modality is one that we've never done, which is we start with science and the humans execute on the science that is there. Now, we've done it in some of the experiments on the space station, kind of in a focused area. What I'm talking about, though, is broad science investigations of the moon of Mars that have a totally different modality. The science requirements go first, and it's clear what the robots do and what the humans do, because at the end, both of them are needed to actually achieve, and the humans are especially needed to achieve these goals. The way we run those, the way we govern those investments, the way we actually fund them needs to be decided, because now it's not so clear who's doing what. If the science mission directorate does not want to fund modality 2 and modality 3, they're not serious. It's actually not good enough. For me, the quality of the science is truly strategic and decadal. So why do I say that that's important? Why do I talk about this today? Our strategy for planetary exploration for the next decade is that just came out, created a profound change in how we look at human exploration, and actually talks about human exploration as not only an important part of planetary science, but one that should be strategically used in a direct fashion the way I just told you. I use my own words, not the words that are here. Go read it yourself. They're other people's words, not my words. And that is, frankly, the broad community. I want to tell you, people who are on the inside, it's like, I've never seen anything like that in the history of science, in which kind of the scientists stood up for the importance of human exploration in the context of lunar science and for the context of Mars science, and the necessity of changing the way we do work. Not because things are broken, it's because we managed to get in through a door into an entirely new kind of space of doing science in a way that we always wanted to do because we never could, because we didn't have modality 1 and modality 0 good enough to get there. Enduring, lasting exploration, Artemis style, requires that we take that seriously and we move forward. By the way, that's a hard discussion. You say, that sounds easy. Everybody wants to do that. Oh, no. Big leadership always has, it's like sitting on your bike. If you don't feel the wind in your face, you're not moving. The changes that I'm proposing requires that scientists are there at the leadership of human exploration decisions, that actually science processes happen before we make a vehicle procurement. We think through that before we push a button. What I'm proposing is the opposite, that astronauts and people who know how they work are part of the science discussions in a way they've never been. That we in fact, take their constraints into consideration. I don't understand how astronauts do their work in a deep fashion. And I would say 95% of everybody who works on my floor at headquarters doesn't either. That needs to change for us to actually open that door. So I'm going to give you just some examples. One of the most exciting things that's going to happen in the near future is we're basically in a process of getting close to basically getting the key milestone of the Perseverance rover ready, which is to basically put a cache of the first set of samples, a fully complete, curated sample set on the surface of Mars, basically ready for pickup. Of course, we're going to try to get even better samples, and we're going to use that to drop off at the launch vehicle that Marshall and Lockheed Martin are building together. That we're going to get off to Mars for the first time, and then in orbit, hand off the precious goods in space to European spacecraft with a US appendage, and then back to the Earth where we're going to Utah. See, I'm already waiting there with my ski pass a few years from now. So basically for me, that, robotic exploration is an amazing precursor. Of course, we want humans there in the future. But that's what we're doing. Eclipse is another really good example of robotic exploration. And, we can talk about this with some of the landers that are being developed. All of them are challenging, by the way. And I could not tell you, if you ask me what's the likelihood that the Eclipse program is going to be successful, it's a little bit north of 50-50, but it's not 90-10. I want you to, by the way, if you ask a leader of the magnitude of somebody who wants to be important in driving the future, if they don't have a program like this, I don't know why they're there. We need to have programs that we're not sure will be successful. That is what we mean with innovation, precisely that. So that's what we're doing here. Of course, we're building capability. And by the way, we're doubling down and moving forward. This is a ride-along thing. So remember, I talked to you about robotic exploration on modality 1. On Artemis 1, we have this ride-along, which is the Near-Earth Asteroid Scout, again, done here at Marshall with the solar cell. First job I ever had was a consultant to aerospace company where I did my grad school doing solar sailing. And, so I just look forward to seeing that, of course, the radiation pressure being used in this case to propel the spacecraft forward and creating a totally different way of propulsion. So as we go forward, kind of riding along, we could, of course, use terrain vehicles, kind of an unpressurized or a pressurized rover that we could use as a ride along, or we could decide to move it to that other modality that I mentioned, this modality 2, in which we could come up with a rover like this and actually say, hey, the time humans sit on that seat, maybe 5 to 10% of the time, that rover sits on the surface of the moon. Now, what are we going to do with the other 90%? Not just as let's do some fun things, such that the human exploration part and the robotic part together answer signs that none of them can do alone. Because we want the human judgment, the eyes of the educated astronaut on the surface of the moon as she looks around and figure out where actually the important rock is that we want to bring back, not the one that we saw from space. That's why we want astronauts. We can't build that judgment into a robot. If you want to, people talk about AI. I think it's really important. It's so important that I took the entire leadership team of science, put them in an AI class last year. I think it's important. But do not overestimate where we are on AI. Otherwise, perhaps you're doing better with the spell checker on your iPhone than I am. It's like, I don't even know that word. What does it mean? I've many times, I'm like, that cannot possibly be a word I ever wanted to state. You're bad at guessing what that is. Anyway, lunar terrain vehicle. The Endurance is kind of a decadal mission in kind of modality 3, which is the one overall to the right. We basically said, hey, there's an impact crater that we think is the largest impact crater that we have observed. And that impact crater, the Aitken Basin, is so important for us to date the entire origin of the solar system that it itself is a highest priority for the decadal strategy, together with everything else, including finding life and exploring planets we've only flown by once, such as Neptune and Uranus. This is a highest priority. The way we can implement that, should implement it, is not as a robotic mission. That's a mistake. The way we should implement it is driving from the top, but the science requires what the kind of samples we have a rover that can traverse a substantial fraction of the order, the kind of drive that I take to go to a vacation, more like 1,000 kilometers as opposed to 1 kilometer, or a marathon distance, which is, I don't know what you run in the morning. I don't, but per year I run 1,000 miles. That's my annual goal, and then almost always make it pretty much. And then I start over. It's like, I wish I could take some miles from last year, because it feels like just the first time. So kind of what I run in a year, which is not that much, but what I run in a year, that's what we want them to do, the rover all by itself, and scout and come up with ideas, bring in, actually collect samples, but then include the humans in the loop and kind of make sure we get the humans to the right place, allow the human judgment in that, then bring that precious good home. We think that by itself, the value of that sample would in every way exceed every sample collection we have on the ground right now, in every lab, hands down. Now, the samples from Mars will compete with that. But that's what we want. That cannot be done in modality 0, 1, or 2. It's a new way of investigating science, and that is what is being proposed. So what I want to do, as frankly, if that's okay, is kind of at this moment in time, kind of slow down and really talk about, kind of stop talking and actually answer questions, because I really want to make sure that you get the key point of this. I could talk about a lot of science, and I don't want to, both about water, about the early universe, my favorite picture of last year, and the investigations we're doing, that we're working on with the Department of Energy, take a shot on goal on the far side of the moon for the first time, ideas that are out there. But what I really want to talk to you about is the amazing opportunity that's ahead of us, an opportunity that has never been here, but it requires that we all recognize that none of us has the solution. So in this case, an argument based on heritage is not the right argument. There is no heritage in building that system in NASA. There's heritage elsewhere, by the way. I actually think our armed forces are better at this. So perhaps they need to be in the room because they're better at it. What I want to do is stop and see whether there's any questions. Thank you.
The room.
He's going to have 10 miles too by tonight, the guy on the stairs.
Thank you, Thomas. Dave Murrow from Lockheed Martin. So my question is, well, first, my thanks are to the inspirational words for bringing humans and robots working together in a new modality. I just wanted to ask you some from kind of your organizational background and what you've seen at NASA. Do you expect that modality 3, which is really important to us, as you've said, will that require organizational changes, or do you, or maybe that's a dry way to ask it, what do you see as the best way organizationally to make modality 3 happen between all of the stakeholders, industry, the NASA centers, NASA headquarters, and of course the science community?
So the short answer is I don't know. But let me add to this. I think sometimes the organization that is built around certain objectives and a certain image of what an organization is supposed to do, that organization is in the way of success because the boundaries are all in the wrong place. But that's almost never the first problem. Like I was part of a venture fund. Everybody always thinks money is the first problem, never the first problem. I always say, suppose I give all the money that you just asked. I give you all that money. What's the next problem you have? Because that's the problem you're supposed to solve right now. Then you get the money. It's almost never the first problem. So for me, basically, if you start working on the organization, and by the way, I actually believe with the arguments that were there, the organization of the Space Force, I'm not saying that just because you're sitting here, General, and thanks for your service. It was clear that the organization was needed to get it the priority that was there. So for me, the organization should follow the recognition of the priority and really understanding what is there. And so for me, what we need to do is start building these teams and figure out when we're hitting the organizational boundaries. If I did it, and remember, I'm not going to do that. If I did it, frankly, what I would do right now is find a place where people can meet and I co-locate them. And actually basically say, hey, you all show up with your badges. I don't care what badge you have. We're putting you in a place and I'm going to put a fast-paced program in front of you that you can actually demonstrate that you understand. And I'm going to make sure that you get to know each other and each other's strengths and weaknesses, because a lot of the cultural disconnects come from things that we don't talk about. When I say exploration, what I really mean is this. When you say it, what you really mean is that. So when we talk to each other, we're actually talking about two different things. So let's be more precise. So it's those kind of things that are what we call cultural disconnect. So I would go after the cultural disconnects first. Once I have a plan, I would now ask the question, is the organization actually able to do it? Frankly, if it was me, what our colleagues and the armed forces has done is basically talking about speed as an important ingredient for culture change. That I would put that on the table too. So basically say, hey, what is the right speed of going forward? Remember, we're talking about running already twice. The trick about running is finding the right speed. If you go slower than your actual stride, it is so tiring, it's boring, it's whatever. If you go too fast, by the end of the corner, you want to turn around because you're running out of energy. The trick is to find the stride. And so the same is true here. So that's what I would do. So I don't know whether the organization is in the way or not, but I would like to figure out. My hypothesis is it can be. But the culture disconnect is a much bigger problem, and I will go after that with a sledgehammer right now.
The last question over here.
Thomas, thank you for your service, and Science Mission Director John Horak from Ohio State. Could you add a little texture or color around the newest part of Science Mission Directorate, namely biological and physical sciences, as it pertains to opening up the right-hand side of your modality chart as you move from, let's say, a directorate whose job is to execute science missions on the left side to a directorate who is focused on executing the mission of science?
Really appreciate that question. So biological and physical science is if you look at the history as kind of a complicated history, with a program that was pretty sizable as the space station came about, and then being basically cut to something like 20% of it. And, what that does, it creates kind of a dinosaur mentality, right? It's a very unhealthy mentality because people are protecting themselves from, in a place where there's a lot of lightning, you do different things than in a place where there's not. You protect yourself. You've met the dog, right, that gets kicked. The dog that gets kicked. So you want to get out of you want to get out of that. So what do we need to do with biological and physical science as it came back in is to include it there. Modality 1 at the space station and other places is going to be an important modality. We want to use the gateway. We want to use the moon as a platform. We want to use commercial platforms as platforms to do this science. But what I really hope from the decadal process that's going on right now by the academy is that it actually empowers us to run the science and the other modalities. I do not know whether the leap is going to be big enough in that decadal. Frankly, the why, the key science of the decadal, I'm very excited that the AA of science does not have to decide that, because I don't know how to do that. So it really is, that's where that inspiration has to come from. From what I'm hearing and the people that are there, we have a really good hope that we can make that leap. My full expectation will be that the biological and physical sciences organization, it kind of adapts and creates that new ability of really thinking that way as part of this kind of next 10-year leap to something that really creates this kind of breakthrough science. Kind of one of the things I've done in every one of our key meeting rooms is put all the title pages of Science and Nature that we have science, put it up there, because that's what it's about, right? Kind of the key breakthroughs that everybody needs to know, because otherwise they're not informed. So we want the same there, as well as the enabling part of that. I think you said last question, right? All right. Thank you so much. Appreciate it.